Hello, Kagglers. Welcome to live coding. I'm just going to double check that I have there we go. I have the notebook I think I have. Welcome. So we have been working on a project for a little while on trying out different automated machine learning systems, or AutoML. And we've also read a couple of related papers in the reading group. And this is just us, kicking the tires, see how things are working. And I've actually done a little bit of extra work this week because I had some time, and I wanna get this project off to a good start pretty quickly. And so far, we've tried a couple different AutoML systems is the word that I was looking for. Woof. And we've also done quite a bit of data cleaning, and I also did some extra data cleaning offline. So I'm going to walk you through what we've done so far, and then what I'm hoping to do today. So the data set that we're using is the Kaggle Machine Learning and Data Science Survey from last year. Am I going to sneeze? Yes, apparently. Sorry about that. The Kaggle Machine Learning and Data Science Survey from last year. We just wrapped up the one from this year, but the data isn't released yet. Once it is, we could use that for a little out-of-fold validation. Hello, Teja, maybe? Teja could be? I don't know. And if you're not familiar with the survey, it's we send it out every year to our users, and we invite the wider data science community to partake. And we ask a lot of questions about methods that you use in your work, your job title, what sort of things, responsibilities you have in your job, if you're employed or if you're a student, what sort of things you're learning. And so we have a lot of information about different data science roles from all over the world. And the survey for last year, we ended up with about 24,000 responses, so it is a pretty large data set. But we're not going to be able to use all of the data because the specific problem that I'm interested in is how can you, given a set of job responsibilities, generate the best job title? So something that's been, I think, very frustrating for people who are in the field, and also people who are both looking for jobs in the field and also people who are trying to work in data science, is that job titles are sometimes not that codified and can sometimes be not super related to the job you're actually doing. Excuse me. So one common complaint is you hire a data scientist who has, deep expertise in machine learning and analytics and statistics, and then you have them set up a data science pipeline, and they're actually doing more like what data warehousing and DBA sort of stuff. DBA is database administrator, which is very frustrating for someone who's like, I have a PhD in statistics. What are you doing with me? You should hire somebody else for this role. So my hope is that we can design a little program that will help suggest potential roles based on what you need the person to do in the role, or potential titles. Hello, Bunty. Ravi says, Happy Halloween. Happy Halloween. Although it is now All Souls Day, which is the day after Halloween. All right. Can I see the column view? There. So the reason we're not going to be able to use the entire data set, and why we have to filter it down a bit. First of all, there's columns that we don't want to use. So we don't want to predict what job role should be based on gender of the person you want in the role. That is straight up illegal. And also probably not super helpful. And age range, another thing that, at least the United States, again, straight up illegal. You can't say, I only want a 20-year-old in this job. Country of residence, I did consider including this, but I ended up deciding not to, because hopefully we do have a very rich global data science community where people can find similar jobs in different countries. So I'm hoping that we will sort of, as a discipline, arrive at a pretty specific set of job titles with very clearly defined responsibilities, and that those will be true regardless of what country you're in, is my hope. Education, I believe we included. Undergraduate major, I don't think we did, just because data science is such a new field. There's lots of people with undergraduate majors that may not be directly related. And then the title here is the specific thing that we're trying to predict. And you can see that the majority of, or not the majority, the plurality of people who responded to the survey are actually students. So we have a lot of people whose job title is student. We have a lot of people whose job title is not employed. And then we have a lot of people whose job title is other. And for the purposes of this analysis, I want to exclude those job titles because those are not job titles you would advertise for. And I also want to exclude very rare job titles. So I believe we looked at job titles with only job titles that had more than 400 people in the specific title. So that's the thinking there. And then we used only some of the columns. And we also had to do quite a bit of encoding of specifically the categorical variables. So you can see here we're going to be using scikit-learn for test chain split. We're using pandas, of course, for tabular data, and then category encoders. Actually, let me edit this. I should be able to edit it. I am an author. There we go. So it's going to take a little bit to spin up the VM, particularly because the data set is quite large that we are loading in. Again, many thousand rows. Well, large for survey data, not necessarily large for all data. And then we have quite a bit of data cleaning, and I've added to this out of off-stream. So Jefferson says, hello, Brazilians are here. Welcome, Brazilians. And everybody else. Tosif says, is it only for image processing problems, or can I fit data science problems, train test data frames? So you want to do a train test split for any prediction problem that you're doing, because you don't want to train a model on all of the available data, because then you have no way to evaluate it on data that it hasn't seen, right? So there's no way to tell if it's overfitting or not if you don't split your data into training and testing. Any means of directly contacting? YouTube's a good place. I also keep an eye on the Kaggle forums, so on the Kaggle forums is also a good place. All right, so things that I have done so far. So we are filtering the, are we filtering them? Okay, so we're looking at question 6 is the question where we have the information on job title, and we're getting all of the titles with more than 500 examples of them in the whole data set. And then we're getting the index of those, and then we're converting the index to a list, and then we do nothing else with it, I think. I think I'm not actually removing unpopular titles. Yeah, I never do anything else with that. So, I guess first off, let's remove unpopular titles. Girl says, you are not, I think? Okay. Hello from Hong Kong. Hello. Remind me what we want to do with the survey in today's session. So given people's job responsibilities and their titles, we're going to predict, given a set of job responsibilities, what title to use, what to advertise for, basically. Is AutoML good for Kaggle competitions? I mean, it depends. Kaggle competitions specifically are about who can build the best model, and generally the best models are ensembles of many different models, so they combine lots of different models and take predictions across of those that are combined in different ways. And my gut instinct is the most useful place for AutoML in Kaggle competitions is going to be as part of an ensemble that also includes hand-built models, but we'll see. And Robbie says, I tried H2O for Titanic and house price prediction. It is awesome. Good. I'm glad you had a good experience. All right, so let's actually drop these popular titles, because apparently I did not do that. And then popular, nope. titles, okay. And then here we are removing specifically the student, other, and not employed job titles, because these, again, are not job titles you would advertise for in a job ad, so that's not helpful. And then we're doing some additional cleaning, but I'm actually going to split this cell here. What is it? Control-Shift-hyphen? Yeah. So I'm just going to split this cell here and then see if it works. All right. So the problem is, based on this error, the problem I'm getting is that this Boolean index is not working to filter the pandas data frame. I'm not actually using filter, I'm using drop. Filters for columns. No, I think filter can also work for rows, but since I already have the index, I don't need to use it. Let's see if that works. Casting as an index specifically. It did not. Okay. So what are we doing here? So here we're finding the titles that have more than 500 instances. Okay, so these are all of the titles. And the ones that have more than 500 are manager, research assistant, data engineer, business analyst, consultant, not employed, research scientist, other, data analyst, software engineer, data scientist, and student. So that part's pretty good. And then here, let's run both of these. We're trying to get the index of the titles in the data frame where those, we're trying to get the index of the titles in the data frame where those, okay, that's not helpful. So I'm trying to get a Boolean array the same length as my data frame, so as many rows as I have in my data frame, with true if the title is in popular titles in that column and false if the title is not in popular titles. Okay, so that is, so far we are getting just the ones that are very popular. Gutter says, can we classify and quantify sickle cells in RBCs? I have no idea. That sounds like a question for Google, unless somebody else happens to know. And Ryan says, I think you want to select popular titles, not drop them. I think you are absolutely correct, but also it's not working because I don't have the correct correct data structure feeding into drop. So yes, drop is incorrect. That's not what I want to do. But also I have messed up. This must be why I converted it to a list, I'm guessing, at some point. Because I think you need a list to do... Okay, well, that's not going to work. That's not going to do it. What I want here is just the popular titles. All right. All right, and I want the names and not the values. And this is a pandas series, it looks like. Okay. Little sip of coffee. Tosif says, how can I import it? Last time it gave me an error, H2O. I have done it like so, and I believe it'll run without an error. Doop. Yep. Geralt says, use isIn on the column with popular titles as the argument, maybe. roll back up. Let's try that. Okay, so we have is in here. And this may or may not work, but we can definitely try. Okay, so we're definitely getting an index out, which is good. And I think I can then use that to filter the data frame. 0, 1, 2, 3, 4. Okay, so that hasn't removed anything. Satya says try popular titles.index. Let's see if that will work. Okay, yeah. And then dot index. Okay. And have we removed anything here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that didn't work because it's looking for a list here and not an index. So I need to cast it as a list, maybe. Let's see if this works. Ye olde guess and test. All right, that did not work. None of index are in columns. Robbie says, coffee, coffee, coffee. Why not declare yourself chief coffee officer of Kaggle? I don't think I'm the person that drinks the most coffee. I'm also in Seattle, which famously is a coffee town. All right. I may also have identified one of the errors. Okay, so this is an index. Okay, so it works as a list, but okay, so that looks correct so far to me. And the problem is here in this the problem is here in this. Bunty says you need to use DataFrame popular title equals true. Dot index. I think that, so I'm assuming you mean here. I don't think that will work because that will cast this, it will cast this, what I have now as a list, which is what is expecting. It will cast that as a series, and I think that won't work, but maybe it will. Ra's al Ghul says maybe instead of list, try to list. That might work. 1, 2, 3, 4. Okay, so that's an index. And let's try that key error. All right, so I can't use this index to filter the data frame. Okay, so the error might be with so the error might be with the very last part. Does this work? Value counts. I don't never remember if it's an underscore in there or not. I think there's an underscore. Oh my god, the tab complete is so slow. Interesting. Okay, so the drop also didn't work because we just ran this little section here, which should drop these values based on the index. Okay, so it's I think it's the correctly removing what I want from the data set that's a problem. And Ryan says, I think it works now. That should be the right selection of rows. Remove the dot index on the last line and see if that works. Consultant, data scientist, not employed, data analyst, and analyst, not employed, not employed, not employed. And it's 14,000 rows. Okay. Yeah. All right. I think that is it. Thank you, Ryan. Okay, so I was actually getting the data frame that I wanted, and then I was creating a new index, and the reason I was getting a problem was because the new index was not the same length as the whole data frame. That makes sense. Okay. So we can get rid of all of our sketchbook stuff here. And now that we've actually removed the popular titles, hopefully the AutoML stuff will take a little bit less long to run, because I believe my last run when I committed yesterday evening took a couple hours, which is not, I mean, awful, but also not really ideal. All right, that seemed to work. That seemed to work. And now let's quickly describe. Is that how you spell describe? There we go. Let's do a quick data frame describe. It's a method. Just to make sure we have everything that we are expecting to have. So Q6, we have 9 unique values. The top is data scientist, which is great. And it looks like we have just the rows that we want, and we only have, there's 4 rows here in the, there's only 4 rows here in the description of this data frame that is the summary, but there are 11,000 roughly rows left. So we got rid of over 2/3 of the data by removing rare job titles and very common job titles. Okay, I think we've got it all worked out now. Thank you for your help, everybody. All right, get rid of you. And I'm going to, I'll leave these in different cells. So the features that we're actually using to predict job title. Job title is, question 6 here is the target variable, so we don't want to use that as a training feature, obviously. And then we have these pieces of information. So level of education, I did include that, but not degree, because at this point I don't think it super matters what your degree is in. Industry employment, so whether the company that's trying to hire is in like finance or technology or agriculture or other industries. Years of experience, so how many years of experience the person in the role has. Compensation, so the salary range for the role. The degree to which the business already uses machine learning, because I imagine that will pretty significantly affect the types of roles that you need if you are already using machine learning. Question 11, I don't remember what it is. Question 12 is the software tools that are used on the job. Question 15 is cloud services that you have familiarity with, so like GCP, AWS, Azure, all of that. Question 16 is programming languages, and then question 19 is deep learning frameworks. All right, so those are the features that we are using for our prediction. And I wanted to do some encoding so that I could do a baseline using just vanilla XGBoost, which does expect numeric inputs. So questions 11, 12, 15, 16, and 19, if we look at the top of our data set, you can see, well, you can't. Nope. there we go. There you can see, are actually split out. So it was a multiple choice question. You could select multiples, and each choice is its own column. So I'm taking all of these multiple choice questions and I am one-hot encoding them. So we're going to end up with a lot of columns here because they're basically already one-hot encoded, but it's with text and not a number if the text is missing. All right. And I'm only getting the ones where there is one unique value per column already, because those are the ones that it makes the most sense to one-hot encode. I don't want to have to deal with the other category, basically, because that's a write-in and people could do anything. So it's going to be a little bit less regular of a feature. You're going to see that in much fewer rows. So. And then I create a data frame with just question 11, and then I do the same thing for questions 12, 15, 16, and 19. And then I use the categorical encoder, one-hot encoder, to transform the whole data set that I put together using one-hot encoding. So that's going to take a second. And you'll notice up here I've already done my split into predictor and target variables. This notebook is kind of a mess. I'm going to go through and clean it up a little bit later. All right, so now if I look at one-hot queues, one-hot here being for one-hot encoding, you can see that I have question and then part, and then a 1 if a participant in that row answered yes, they do use whatever thing that is, and a 0 if they say that they don't. And I ended up with 102 columns because there were a lot of potential options. And I don't think all of these are going to be, are actually going to be very helpful when deciding what job title to use, but some of them will be. So we're going to have to use models that can handle high dimensional space and kick things out. And hopefully AutoML will do that for us. So, all right. And then for the rest of the questions, we do something a little bit different. Okay, yes, that does work. I was like, wait, am I overwriting this with this? I am not. So for questions 4, 8, 9, and 10, I'm doing ordinal encoding. And then for question 7, I'm doing one-hot encoding. So ordinal encoding would be for each level of a categorical variable, you assign it a value. Good example would be, you might have city blocks on a map, and you might look at the map and you say, okay, the one in the, northwest is 1, and then 2, 3, 4, 5, and then go down to the next row, something like that, and use that to refer to the city blocks. And I'm doing that with these questions, the salary, the education level, things like that. And then for question 7, I'm doing one-hot encoding. And I forget what question 7 was. Let's check our little data dictionary here. Oh, right, industry of employment, because you might work at in multiple industries at the same time. So you might have something that does agricultural finance, and that would be in 2 industries. And then I'm taking this encoded piece of the data, and I am adding this additional encoding to it. And then I'm adding the one-hot questions to the questions that I've cleaned. And finally, I am encoding the Y variable as well for algorithms that expect ordinally encoded target variables, if that makes sense. Here's one I made earlier, basically. And I think we actually did this on the channel, so y'all can go back and watch that if you're interested. And then I did my test train split twice, and once with the non-encoded Y, so where this is just the text of the job title, and once with the encoded Y, where you have the not the text of the job title, but rather the actual a numeric value for each possible job title. And the reason is that that's what things like XGBoost expect. Oh, look, it's XGBoost. If any of you are have been on Kaggle for a while, you know that this is one of Kaggler's favorite algorithms. We covered on our Learn material, it's gradient boosting algorithm. People also like cat boost or like GBM, or there's other gradient boosting things, but they tend to work pretty well. So I'm training just a very basic XGBoost model as a comparison for the AutoML models. And hopefully the AutoML models will do better than just regular XGBoost with the default parameters, is the hope. And we also have a while to wait because there were a lot of columns. As you can see, I was using all of the CPU. You can parallelize it, but I didn't want to futz with it. It's very easy, I remember. I'm lazy. It didn't take that long. All right, so if we check out some information about it, we got 52% accuracy, this is not a binary classification problem. This is, I think, a 7-way classification problem, 6-way classification problem. Actually, that is extremely find outable. 2, 3, 4, 5, 6, 7, 8, 9. It's a 9-way classification problem with pretty imbalanced classes. So accuracy is actually probably not going to be the best measurement here, because in situations with imbalanced classes, if you always guess the most common class, you can get good accuracy, but not good utility from your model. So these are the classes that we are. And I'm just going to add this out back here at the end. Look at classes and imbalances, just because I think that'll be helpful for people coming by and reading the notebook later. So overall, we've got about 52% accuracy, which with 9-way classification is well above chance. And I also have done a little confusion matrix here because I think that's helpful. So along the axis, you want the counts, the sort of like center line, you want the counts to be higher because this is the correct class and this is the predicted class. It's usually the way it is. And things off of this center line are errors. So you can see whatever this first column is, it looks like the correct class does occur more often than any other classes, but most jobs in this range are not being assigned to the correct title. This one's abysmal. This one's pretty good. This one's okay. It's actually not that bad. This one's pretty good, but it seems like there's a lot of confusion with whatever this one is in the third row, which is the same as the one in the third column. This one is gosh awful. I'm guessing this is probably like a management one, or maybe I think developer advocate was also a very small role. Oh yeah, that didn't even make it. And then this one was pretty good. A little bit of confusion with this one. This one was very good, whatever this role is over here. And then this final one, even though there were quite a bit of errors, looks to be pretty good as well. So some classes seem to be more difficult than others, harder to correctly assess. Is there like a names argument here where I can add my names maybe? Nope. Labels maybe? Labels from Y maybe? Will that work? No, that will not work. All right. So I'm trying to get a way to be able to see not just the raw counts, but also which classes are being confused with which other classes. Robbie says diagonal are all correct prediction. Am I right? Yes. So you want the count on the diagonal to be higher. All right. Let's try. So we had Y encoded. And then we had, let's see, so this is Y test specifically is what we're looking at here, except it's the encoded one. Do the encoders themselves have a way to save the pre-encoded information? That would be helpful. I'm guessing that they do, actually. Except when we use multiple encoders, it's possible that we have overwritten previous ones. Let's see. Usage, encoder, encoder transform, backward difference coding. I think this is a specific type of encoder. Backward difference contrast coding for encoding categorical variables. Fit, get features names. Returns the name of all transformed / added columns. Get parameters for the, perform the, get feature names. Okay, so I think get feature names is actually what I want. And luckily the encoder for the one that I want is the one that I did last. So let's see if that will work. Ashwini says, can you put the label name in the confusion matrix? That's what I'm working on now. All right. Okay, so it was a feature, right? Get feature names. So it told me the name of the column, but not the name of the features, which is what I wanted. Get names back. I want to undo it. Backward difference, backward difference, backward difference. Backward difference coding, which I'm pretty sure is just a type of, excuse me, I'm pretty sure that's just a type of encoder. Okay. I want my names back. So my problem here is that I didn't set, when I did my trust train split, so I can't just use the Y train, or the Y test, which you will see is a list, because I did the split in different ways. Although if I still have do I still have the indexes? I do still have the indexes. Okay, so I should be able to use the indexes to get the information back out. All right. I want to get the information back out. Can I do df q6.isIn? Will that work? No, that will not work. Oh, that's right. It won't work because it's that didn't work. Let me try that. Nope. Yep. Link. It looks like these are all false, but I could be wrong and I could just be getting unlucky. Nope, they're all false. Okay. So that's not it. Okay, so assuming, so the other thing I'm thinking about is we could try the proportions of the overall value counts to try and figure out which one is which. But unfortunately, some of them are very close. So consultant and data engineer, and then manager and research analyst, for example, are very close to each other in count. So if we are sampling part of this data set in a random way, we don't know that the very rare thing like the most rarest column, is that going to be manager or research assistant? These are so close that when we have sampled from them, there's no way to tell. Not sure. Robbie says, lots of libraries and tools. Which tool should I use? I'm a beginner. Depends on what you want to do. Okay. And the encoder doesn't have that many methods, does it? Get parameters, get feature names, handle missing, handle unknown, mapping, ordinal, transform, mapping maybe? List object is not callable. It exists. Okay. It just, for some reason, didn't show up in the documentation. All right, so we have our information here. And what we need to do is use this information as the... Oh, these aren't in the same order, though, because data scientist was the most common name, and that's not what we have here. Maybe I can use this for labels, potentially? Let's see if that works. I don't think it's going to, but it might. No, that didn't work. All right. At least one label specified must be in Y true. So I'm trying to do a mapping between the labels and the labels of the data point and the numeric ones, because I've encoded it, and then the non-numeric ones. And the reasons that I have encoded it numerically is because otherwise XGBoost throws a hissy fit. All right. So we have, okay, so this is, encoder mapping is what we want to get the information out. Dot value counts. Hold on a minute. Am I not using the encoded? Oh, no, yeah, I'm not. Okay. What have I been doing? All right, noted. Ashwini says, can we use a heat map here? Yeah, a heat map is a, in this case would be an additional visualization on top of the a heat map would be an additional visualization on top of the confusion matrix. All right. So I think what we need to do is check out the sklearn confusion matrix, sklearn, and see if we can find the arguments here that will add the labels. All right. So it looks like I was right about that's what we need for the labels. But does it organize these by order in which you give the labels? Maybe? That would make sense. Okay, so in that case, the let's see. Ryan says, labels is not going to do what you want. Just looked on sklearn and it just grabs a subset of the columns instead of adding the words. Love it. Why is this so hard, scikit-learn? Why is this so hard? It's built into R. Okay, here's a pretty one. Can I have this one? I want this one. And there's your heat map for who asked about heat map? Is this Nato maybe? All right, so we've got our heat map, blah, 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 blah. Plot confusion matrices. We need to give it classes. All right. Okay, so let's try this. Where classes is class names. Okay. All right, let's give it the old college try. So this defines a function that does not work because I need to import pyplot. Let's see what else is not going to work in here. Did I miss any other imports? Okay, I think that's all I need right now. And I do need the class names, which they are getting by dot target underscore names. Is that a normal function? All right, let's see. I don't think this is, yeah, no. Okay, so that's a built-in. Names, is that a built-in? Nope, okay. All right. So this needs you to pass in the classes. So I still need to get the names. And if I just try to do it without, it is not going to work. All right, so we have our function. That's all great. Y test, Y pred. So it was predictions, and then I think we did call ours Y test. So I need to come up with this classes name information. Ryan says, for you, that would be the original Q6 test. I think it needs it to be unique, maybe? Let's try giving it Y train, maybe? Let's see if that works. No. Oh, Y test, actually, I think is what I called it. Yep. All right, name unique labels is not defined. All right, where are you getting unique labels from? Aha. It's a scikit-learn utility. Okay. All right. Name NP is not defined. Yeah, right. Can fix that. Import numpy as NP. Okay. So I'm going to zoom in on this so you guys can see that these are all not a number. Helpful. Okay, so what I need is the unique names of the... What is it even doing with the classes? What is it doing with the class names? Target names, and then it's getting the... Where is this actually getting used? Only use the labels that appear in the data. Unique labels. Okay, so can I try, what will unique labels df.q6 give me? All right, I think that'll work. Because it won't just take the raw input. I think it needs all of the unique labels. No, that did not work. Arrays used as indices must be of integer or Boolean type. Okay, what are you expecting from this data structure-wise? What data structure are you looking for? Gotta mess around with Iris again. Okay. Boop, boop, and then did not work. That must be another skit. Yep. Another scikit-learn utility to load in the iris data. But then we can check the data type. Then we can check the data type of the class names thing and figure out what we need. It's an array. What's the difference between my array and your array? What am I doing wrong? It's an array. Is it the data type? UT18 versus UT10? Alright, peace out, I don't need you anymore. Peace out, I don't need you anymore. Ryan says, try passing Q6, no unique classes. That got me an error. Well, it didn't give me an error, it just got me a bunch of not numbers. So it looks like that's not going to work for this one, unfortunately. And it looks like what they were putting in with the, in their example, is the array rather than the, all right, that's an array. That's a series. Maybe that's the issue. Maybe it's a combination of an array and series that's getting me the problem. Enrique says NumPy or pandas array. So ytest is a NumPy array. Excuse me, a pandas array. Predictions is a NumPy array. Although it's object. Yeah. I'm pretty sure that's NumPy. And then the classes is also a NumPy array. Yeah. So, what is our problem? Arrays used as indices must be of integer or Boolean type, used as indices. So the problem is with the unique labels. So what if we just take, instead of doing Q6, what if we take it from ytest and then get rid of this line. Peace out. Get rid of you. Get rid of you. Try that. That did it. Okay, so it was just like the weird classes comparison thing that they were doing, which because I was trying, I think the problem is that I was trying to compare arrays of different types. And now, at long last, we can look at our beautiful plot and learn things from it. So I'm going to get rid of this confusion matrix bit here. Accuracy. But this is an imbalanced multi-class prop. Multi-class prop. Okay. And I'm just gonna do my hack and use the unique names from one of the prediction classes instead of the input class. That's my strategy, and I'm sticking to it. So let's look at this guy. I'm gonna open in a new tab because I think that'll make it. Oh, that's so much worse. I was like, I think this will make it easier to read. It don't. Let's change the theme. It's light theme now, just for ease of reading. So the ones that tend to get confused with each other. So data scientist, the most common job title, the one that we're looking like it's the best It's the one that this model is the best at identifying. Software engineer is looks like one of the more confusable job titles, or the one that's left. Research scientist seems to be fairly easy to pick out. Research assistant and research scientist are confused with each other a little bit. And actually there was a normalization option as well, right? Yeah. Okay, let's normalize just so we can not have to look at raw numbers with our human eyeballs. Oh, Jiminy Cricket, that's awful. That's so bad to look at. All right, but the things you can see from the normalized is that overall the model does fairly well. Data scientist is fairly confusable. Manager is also fairly confusable. It looks like manager and consultant tend to get confused with each other quite a bit. Data analyst and data scientist tend to get confused with each other quite a bit. And then data analyst and data engineer, that's also a little bit muddy. And then manager has some overlap with business analyst and consultant. Which, I mean, this could be helpful for you if you're trying to pick a job title. And then I'm going to get rid of the normalization because it's horrible. It's so bad to look at. That's better. So overall, not an awful start, but the hope is this is our baseline, right? This is our let's actually, first off, let's hide this in the notebook and then hide the input and the output when you go to look at the compiled version. So my hope is that the models will do better. The AutoML models will do better than our reasonable baseline, which is just vanilla XGBoost, no tuning. All right. Jasper says plot.figure figure size 1515, just to make it a little bit bigger. Yeah, I can try that. Santosh says, can you give some inputs on how to reach top 10 rank in Kaggle competitions? Even though I use state-of-the-art models, I'm unable to reach the top 10 in any competition. There is a lot of mysterious. Okay. There's a lot that goes into Kaggle competitions. Usually the winners do smart feature engineering and use ensembles of multiple models. So I would say use multiple models. Can I just do... Will that set it for... Okay, and this looks like it returns two things, so let's do matrix figure, maybe? See how that works. Axes subplots object is not iterable. Is there just like another thing in here? What are you returning? I'm trying to make the figure better. Did I read the YouTube comments? I do usually read them. I don't know that I went over them yesterday. Alright, helpful. That did not work. So that, to change its size, I think the easiest thing is actually going to be to do it in the one that we've hidden here. If normalized, blah, blah, blah. Axes set, plot.set. Figure, axes, plot.subplots. Return axes. All right. Let's see. And I don't actually want the confusion matrix printed out, so let's comment that out. All right. So it looks like I should be able to just do fig dot. People being like, you may have to change the, and by people here I mean Jesper, you may have to change the function. Yes. Let's see. Figure equals 15, 15. Do I need to assign that, or will it just work? What? Why? Expected indent block. Expected an indented block. Why do you expect an indented block? Is it because I commented out the print? Expected an indented block. All right. Okay, it's something to do with the comments. Did I accidentally add a space? Oh, it's because there's no else now. All right, actually, y'all can just all peace out. Okay, and then what was I doing? Fig, and then I don't know if this is gonna modify it in place or if I'm gonna need to assign this back to Fig. We'll find out. That work, excellent. And now plot that. Figure object is not callable. All right. Oh, okay, so maybe it is. I have to use that. Did I actually run this? All right, that didn't work. And it got unexpected keyword argument fig size. Yeah, fig dots set fig height. Oh, down here. I see. All right. Get rid of you. Set fig HEIGHT 15. Dang, that's that. H15. All right, let's try that. Are you angry? Yay! Thank you, Jesper. That is much better with the eyeballs. Is there any good resource to learn Matplotlib object-oriented API? I don't know. We did figure it out. So, Time Traveler says processing control plus comment anywhere on the line. Oh, let's see. Control comment? No. It doesn't look like it's working for me, but I take your word for it. That might be a editor specific thing. All right. Excellent. Okay, so today it's time to finish up live coding. We have done one very beautiful visualization, which I'm actually okay with because this is for multi-class classification, part of model evaluation is to look at the confusion matrices. So I am fine with that. Yeah, it's also very interesting to see the confusion between different roles and what seems to be most commonly confused with each other. Yeah, like research assistant and research scientist, I'm not surprised by. Those are very similar roles. Some of these others are also very interesting. All right, so I'm going to commit this, and I don't remember if it's public or not. I should probably make it public, huh? So you guys can check it out. And we will be back next Wednesday for more of the paper reading group. We'll continue to read that sunbeam on my face. We're going to continue to read that paper that we've been working on about updating chatbots after deployment using user feedback. So yeah, if this were an R, it would have taken me 3 minutes max, but I'm trying to get better at plotting in Python, so hence the dragging myself through it. All right. Jesper says normalize it. All right. We'll try the normalized one. Get rid of that. And it's taking a while to run because further down in the notebook that we did not get to is, there you go, there's the normalized one. Further down in the notebook that we did not get to, I got Teapot up and running. Teapot is sort of an old school, it's been around for a couple of years, AutoML algorithm. And then I also tried H2O AutoML. And the most important thing here that I just want to quickly pass on before I wrap up is it's looking for the H2O frame, which is a different flavor of data frame from pandas. So you need to convert your pandas data frames into H2O frames. So just FYI if you are using AutoML. That tripped me up a little bit, and then this one takes quite a ways to run. Again, it's a very wide data set. There's, actually that's something that I can tell you, huh? And then X, I think it was X cleaned dot describe. So as you can see, there are quite a few columns in the data frame. So, and I think that's going to be about it for today. This will run. It'll be available. Oh, let me make it public while I'm thinking about it, so you guys can check it out. And I'll be adding additional methods over time. Public. Okay, make public. And it should be data cleaning plus AutoML. All right. Thank you for joining me today, everybody. People in the chat, plotting in Python is so confusing. Yeah, agreed. Please next time H2O live session. I was hoping to get to it today, but we got distracted, how we say, by plotting in Python, which is always a bit of a slog. Yeah. And the repo, for people who are asking, is going to be at this address, and it will load for you. I just need to clear my cache. Okay. Thank you for joining, everybody. Have a great weekend, and I will see you on Wednesday, or before then, on Kaggle. Thanks for joining. Bye.